Okay, let's discuss the next heading, that is mean velocity. So, what is mean velocity? First of all, the velocity of flow, which is measured at surface, is called as surface velocity. But this surface velocity will not be constant at all depths. Obviously, it will be different at top, and at mid level it will be different, at the bottom level it will again be different. So from observation it has been found out that velocity at 0.6 d will be the mean velocity. The velocity which will be measured at 0.6 d will be a mean velocity. After a long investigation, there are two researchers who have given their equations for mean velocity. One is Chasey and the another one is Mannings. Chasey has given an equation V equals to C under root Rs, where C is the Chasey's constant. R is all of us must know that R is hydraulic mean depth. The formula for it is A by P. S is the bed slope. Whereas Manning has given the equation as V equals to 1 by n R to the power 2 by 3 S to the power half, where n is coefficient of rugosity, the value of which will be directly given to you. Whereas the rest are known to you. R is hydraulic mean depth, S is the bed slope. Okay, let's come to critical velocity ratio. Critical velocity ratio is nothing but a ratio of mean velocity. It is the ratio of mean velocity to the critical velocity, where CVR is given by the term m, mean velocity by v, and critical velocity by VO. When you will have the value of m equals to 1, that means it is a condition of no silting nor scoring. That means in a channel there will be no silting occurring, neither a scoring occurring over there when the value of m is 1. If CVR is greater than 1, that means velocity is more, so scoring will take place. When m is less than 1, that means velocity is less, so sedimentation, that is silting, will take place. Okay, thank you.